Welcome back to the Deep Dive, where we filter the flood of information into the essential insights you need. Today we're doing a really critical deep dive into something that impacts you, well, every single second, yet you probably rarely think about it: your sound environment. Our mission is to move past the simple, blunt measurements of volume, the decibels, and really analyze the complex, subjective, human-centered world of the soundscape.
We're pulling apart some very rigorous academic work today. It's primarily a large PhD thesis that combined these huge field studies in London with some very controlled laboratory experiments. And the goal here is to understand not just what makes a sound loud, but what makes it stressful or what makes it pleasant, and how your mind and your body actually process those things differently.
Okay, so before we get into that subjective experience, let's just establish the objective danger. Because noise is a massive public health risk, especially in cities. And the World Health Organization is actually quite specific on this.
They really are. And the definition of noise pollution, it starts much earlier than most people think. Unwanted sounds, what we think of as classic noise, are considered pollution when they go over 65 dBA.
And 65 dBA is what, roughly the level of a busy office? Or a vacuum cleaner running? That's a daily reality for millions of people.
It is, yeah. And the danger escalates really quickly. Noise becomes actively harmful above 75 dBA, and then it crosses the threshold into outright physical pain above 120 dBA. And crucially, if you care about restorative sleep, the WHO states that restful sleep is, well, it's functionally impossible when nighttime ambient noise levels get over 30 dBA.
30. That's quieter than the library. It just emphasizes how fragile our rest really is.
Absolutely.
So clearly, traditional loudness measurement is vital for public health. But this research moves us past just measuring the acoustic physics to this concept of the soundscape. It's a completely different lens.
Exactly. The Soundscape asks, how do people experience this environment? And researchers define this experience using two core perceptual dimensions, which are rooted in models of human effect. They are pleasantness, which is the valence, how good or bad you perceive the sound environment to be, and eventfulness, and that's the activation or arousal level, how busy or intense or stimulating the environment feels.
So we're dealing with two sort of orthogonal feelings, happy, sad, and calm, dizzy. Let's start with the human side of the equation. The thesis drew on this massive real-world field study. It was across 11 diverse locations in London, pulling over, 1,100 participants?
Yeah, a huge data set.
So what did it tell us about how factors about the listener shape their perception?
Well, this section really highlights the subjective variability. The research looked at factors like age, occupation, and even your psychological state. First, they found a positive link between higher psychological well-being, which they measured using the WHO-5 index, and a higher rating of soundscape pleasantness.
So if you're in a generally better mood, you're more likely to think the city sounds nice. That makes a certain amount of sense. A positive filter helps.
It does, but the relationship with the feeling of eventfulness was much more nuanced. They found a specific negative correlation. Psychological well-being was negatively associated with eventfulness only in two specific demographic groups: males and individuals who, for whatever reason, declined to report their occupation.
Wait, why that specificity? Why wouldn't that link apply across the board? It almost suggests that for some people, maybe those with less defined or stable environments, that lower well-being might be manifesting as a heightened perception of chaos, of busyness in their soundscape.
That's a key interpretive layer. It suggests that the perception of high arousal or high eventfulness might be an objective environmental stressor, but the subjective interpretation of it as negative might be linked to, an underlying psychological fragility, particularly in demographics that are perhaps less rooted or reporting lower overall life satisfaction.
Another powerful factor they identified was occupation status, specifically retirement.
Yes, retirement status was a significant predictor of soundscape appraisal. Retired individuals consistently reported higher pleasantness and lower eventfulness when they were rating the soundscapes.
And the researchers interpret that retirement status as a proxy for increasing age, so typically individuals over 65.
Yes. The findings suggest that as people age, their appraisal of soundscape pleasantness goes up and their perception of busyness goes down. Whether this is due to physiological changes, psychological shifts, or just less exposure to those high-energy, high-event urban areas, the correlation is strong. Getting older makes the world sound nicer.
Okay, we've established these clear demographic and psychological links. But here's my challenge. The study found that listener-related factors accounted for a tiny fraction of the total perceived variance, just 1.4% for pleasantness and 3.9% for eventfulness. If the listener's state of mind accounts for so little, shouldn't we just ignore this data and focus purely on the location's acoustics?
That's a fair and critical question. But, 1.4% of thousands of perceptions is still a significant trend to note, especially when you're thinking about vulnerable groups. However, the finding does confirm that for large-scale soundscape design, the primary focus has to be on the location itself. The overwhelming majority of the variance in pleasantness is explained by where you are. Is it a bustling market or a quiet park? Your psychological well-being, it just colors the experience. It doesn't define it.
So the subjective mind plays a minor role in coloring perception, but the objective sound environment, that dominates, which forces us to move from the mind's interpretation to the body's hardwired response.
Exactly. We are shifting now to objective, unconscious physiological measurement. This is where we find out what your body is doing, regardless of what your brain thinks about the sound. We're looking at how loudness triggers our ancient defense mechanism, the autonomic nervous system.
And the researchers use skin conductance response, or SCR. You might also hear it called electrodermal activity, or EDA. Explain what this index of stress response actually measures for us.
SCR is a direct objective measurement of arousal and stress. It measures these tiny transient variations in the electrical conductivity of your skin. This conductivity changes because the sympathetic nervous system, that's your fight, flight, or freeze mechanism, it activates your sweat glands.
So your skin just gets a little bit damper.
Precisely. And this is regulated by the neurotransmitter acetylcholine. Think of acetylcholine as the sympathetic nervous system's way of sending this rapid, nonverbal message to your sweat glands that says, attention, something is happening. So SCR is an index of how alert or stressed or aroused your body is, and it completely bypasses any conscious thought or judgment.
Okay, so the researchers then ran a really crucial lab study. They compared natural sounds like birdsong or waterfalls against mechanical sounds like a car horn or a grinder. But they did something clever. They equalized the perceived subjective loudness across all categories using a psychoacoustic unit called SOUN.
This is a critical technical point. We usually use decibels, dB, which measure acoustic pressure. Sones, however, are a nonlinear psychoacoustic unit. They measure perceived loudness, so 10 sones is perceived as twice as loud as 5 sones. By equalizing the perceived loudness to 10, 20, and 30 sones, they made sure that the sound category natural versus mechanical was the only variable, not just physical intensity.
And what did the SCR measurements reveal about the body's reaction to that loudness?
They found a definitive, very straightforward physical response. SCR amplitude was overwhelmingly driven by the loudness level, the intensity in sones. Higher loudness led to a higher, more dramatic SCR. Volume dictates the physical stress response.
But the real insight comes when you compare the category of sound. Was my body less stressed by a loud, rushing waterfall than a loud, roaring traffic jam?
And here's the finding that creates the aha moment. There was no significant difference in SCR amplitude between natural sounds and mechanical sounds when they were presented at the exact same loudness level.
That is profound. You are telling me that if I am listening to highly enjoyable nature sounds at a high volume on my headphones, my body is engaging the same physical, unconscious stress mechanism.
Yeah.
The same attention. Something is happening. Signal, as if I were standing next to a jackhammer of the same volume.
Absolutely. The body only registers intense energy. This implies that regardless of subjective pleasantness, prolonged, intense exposure, which the source says is consistently triggered above 85 dBd SPL, will consistently trigger that autonomic nervous system activation. Your conscious enjoyment of the sound does not negate the physical stress the intensity places on your system. This is why noise remains such a massive public health issue. The damage can happen at a fundamental, unconscious level, even if the sound is subjectively labeled good.
That connects back to the WHO data perfectly. Volume is the primary culprit for physiological harm. Full stop. Now let's drill down into why some sounds are subjectively rated as pleasant or unpleasant, even when their volume is controlled. If volume is the stressor, what is the structure that defines our aversion?
This brings us to psychoacoustics, the study of how we perceive sound properties. The researchers focused heavily on spectral contents, specifically a measure called sharpness.
Sharpness. That sounds like a physical sensation.
It is, in the acoustic sense. Sharpness is the perception of energy concentrated at high frequencies. It's measured in a unit called occum. Think of occum as measuring how grating or squealing a sound is. A deep bass note is low in sharpness. A brake squeal or a fingernail on a chalkboard is very high in sharpness.
And the research pinpointed exactly where our auditory system is most sensitive to that aversion.
It did. It identified the frequency range of 2500 to 5500 hertz as contributing maximally to unpleasantness and annoyingness. And here's a fun fact. Your ear canal has a natural resonance in this precise range, which means it physically amplifies these specific high frequencies by up to 30 dBA. Our own biology makes us highly attuned and highly reactive to these annoying high-pitched sounds, and conversely, lower frequencies tend to be perceived as more pleasant.
So that high-frequency spectral content doesn't just contribute to unpleasantness. It also drives that feeling of high arousal or eventfulness, right?
Yes, that high spectral energy is a double whammy. Sounds characterized by high spectral content, lots of energy in those upper frequencies, were perceived as more eventful. This explains that subjective divide. Mechanical sounds are inherently more unpleasant and more eventful because their source structure often generates more of this activating high-frequency energy.
The researchers even validated this connection between high-frequency content and the feeling of busyness using a particularly clever test, vocoding.
Right. They took complex sounds and intentionally degraded them by noise vocoding, which basically strips away those sharp spectral cues. And when they removed this high-frequency information, the subjective differences in eventfulness ratings between natural and mechanical sounds decreased significantly. This confirms that when you are judging how stimulating or busy a sound is, your auditory system relies predominantly on these spectral cues, the frequency makeup above all else.
So, subjective aversion isn't arbitrary. It's hardwired into our auditory processing because high-frequency energy is inherently associated with both unpleasantness and arousal thanks to our ear's own mechanics.
It's a truly bottom-up, acoustic-driven reaction long before the brain applies any label like pleasant or stressful.
Okay, now let's explore an area where the scientific search for objective measures kind of hit a roadblock. We found an objective measure for volume-based stress with SCR, but can we find an objective physiological index for subjective pleasantness or calmness? The researchers tried to use objective ocular responses, eye movements, to correlate with complex sound properties, specifically using colored noises.
This was a fascinating attempt to link the mathematics of sound to our internal state. The study looked at sounds defined by their 1 Hess slope, or, how their power changes across frequencies.
It focused on 3 colors, right? White, pink, and brown.
Correct. White noise has equal power across all frequencies, so that's a slope of 1F to the power of 0. Brown noise has power that decreases steeply, 1F to the power of 2. But the critical one was pink noise, where power decreases slowly, 3 dB per octave, or 1F to the power of 1.
And pink noise is theoretically special. Why did researchers think it should be the calmest?
Because that 1F slope pattern mathematically resembles so many natural processes and physiological rhythms. Things like ocean waves, fractal patterns, certain neurological activity, even the long-term changes in a beating heart. The hypothesis was that the human nervous system is so accustomed to this natural rhythm that pink noise should elicit a distinctly calmer or more pleasant physiological state compared to the flat white noise or the deeply resonant brown noise.
So they were searching for objective physical proof of this mathematical calmness, and they used eye tracking.
Yes. They measured pupillary diameter response, or PDR, which acts as a robust, nonverbal index of overall arousal. And they also measured microsaccades, those tiny, involuntary eye movements, as a potential index of attention or even pleasantness. These are purely objective indices of nervous system function.
So did the mathematically elegant pink noise prove to be physiologically superior? Did the pupils dilate less, indicating less stress, compared to the chaotic white noise?
Conclusively, the objective measures failed. The ocular responses, neither PDR nor microsaccades, showed any significant differences across the brown, pink, and white noise conditions.
That's a major null result, especially for something that has entered the popular consciousness as a therapeutic tool.
It raises an important question. It suggests that the effective dimensions we attribute to colored noises, the calmness of brown noise, the natural rhythm of pink noise, they may be primarily mathematical concepts rather than reliably acknowledged by our auditory processing system or our nervous system in a measurable, transient way. When you strip them to their core structure, the body treats them essentially the same.
So the science says your $20 app playing calming pink noise might just be a placebo, at least when measuring acute physiological response.
Or it suggests that the effect relies heavily on context, expectation, or prolonged exposure, which the transient lab test just couldn't capture.
So what does this entire deep dive into the soundscape mean for you, the person walking through a noisy city, or simply choosing a calming environment? Let's summarize the three core actionable insights we distilled today.
First, remember that individual variability only slightly colors sound perception. While your psychological well-being and life stage, like retirement, do positively influence how pleasant you write a soundscape, these factors are minor compared to the acoustic quality of the location itself. Fixing the environment matters far more than fixing your mood.
Second, and this is the most critical public health takeaway, loudness dictates the subconscious stress response. If a sound is intense, regardless of whether you consciously perceive it as pleasant, be it a roaring ocean or roaring traffic, it triggers the sympathetic nervous system and your physical stress response, the SCR. Your body is registering that intensity as a threat, potentially leading to chronic health issues with prolonged exposure.
And finally, acoustic properties drive subjective aversion. The primary acoustic trigger for unpleasantness and arousal is high-frequency content, especially in that 2500 to 5500 hertz range. Mechanical sounds are inherently more eventful and unpleasant precisely because their spectral structure contains more of this grating, high-energy information.
This entire investigation focused so heavily on immediate reactions, what happens when sound hits the ear in a single moment. But our acoustic world is rarely static. It's a dynamic, persistent stream of sound.
And this leads to the fundamental question for future research. How does the nervous system adapt, or perhaps malfunction, when that stress response is triggered minute after minute, hour after hour? We need to investigate the effects of sound duration and temporal dynamics.
The sources suggest that methods like recurrence quantification analysis, or RQA, which is used to analyze nonlinear time series data, could be the key to understanding auditory adaptation. It would help us see how the nervous system adjusts, or, crucially, fails to adjust, to the persistent flow of sound over long periods.
Understanding the dynamics of that persistent sound stream and how the body's stress system eventually gives way under chronic noise exposure, that is a vital next frontier for soundscape research. It's the difference between feeling stressed for a moment and developing a long-term stress-related illness.
How we adapt to that persistence, that's a profound thought to mull over, especially for those navigating busy, noisy urban areas every day. A big thank you for decoding the soundscape with us.
Always a pleasure.
That's all the time we have for this deep dive. We hope you feel thoroughly well informed.